Welcome to the Transum podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Happy New Year, one and all. This is the Transum podcast number 134 for January 2026. Well, let's get going straight away with the puzzle of the month.
My New Year's resolution is to paint the long fence that goes all the way around Tran Towers. In January, I will paint 1/12 of the fence. In February, I'll paint 2/12 of the length of fence remaining. In March, I'll paint 3/12 of the remaining portion of the fence and so on throughout the year. When during the year will I require the most paint?
That's the Transum Puzzle for this month. The challenge is set. Have a think. Make a plan. You have 1 month to figure it out. Send in your solution as soon as you can.
And I guess I could throw in an extension for rocket scientists for this puzzle. What if there were X months in a year instead of 12? Okay, let's see what you do with that. And if you get an answer, of course, I'd love to hear how you solved it or your student solved it. Fire off an email to podcast@transum.org. And while you think about that, here are some of the key resources added to the Transum website during the last month. Jack Frost Fractions is a new interactive activity in which students frost the panes of a window to satisfy a set of fraction clues. They work with fractions of a whole grid and of different regions. So there's like a top section, a left section, and particular rows. And they must use these fraction clues to fill in the patterns that obey those rules. So it's a bit different from doing routine calculations, and the idea came to be mid-December. I put it as a late addition to the Chris Maths collection, but as it's got more of a general winter theme, I've chosen to introduce it in this January podcast. Moon measures is a particular estimating activity that can lead to some rich follow-up work, I guess. As students work through the questions, a result table is built up showing their estimates, percentage errors, time taken, and their running score. If they copy and paste this table into a spreadsheet, it opens the door to a great deal of meaningful mathematics, calculating averages, comparing performance on different scales. They could create graphs, I guess, of their error against distance or time, and basically discuss what a good estimate looks like. So there's a lot of potential for moon measures. Now, all the things I'm talking about here in this podcast, the links can be found in the newsletter, transum.org/newsletter. So please go and have a look, or just use the search page to search for the title of the activity. A new year is the perfect time to raise the subject of time in your maths lessons. And I'm always surprised by the students who can use the formula to solve quadratic equations, but they don't know the number of days in the months of the year. So, you could start with the 1st of January starter, which includes some time calculations, and you may want to show the video I've just added about the etymology of time words. And just for the student who thinks they know it all, ask them the meaning of bi-monthly. Does it mean occurring twice a month or once every 2 months? What do you think? My dictionary says it can mean both, so perhaps a survey is called for. Alright, some January dates that are worthy of a mention in a maths lesson. On the 4th of January, it's World Trivia Day. And of course, there's lots of maths trivia in that section on the Transum website. On the 29th of January, it's Chinese New Year. And there's a Chinese New Year section on the Transum website. And on the 29th of January also, it is International Puzzle Day. And as you know, there are plenty of puzzles on the Transom website, so good excuse to do some great recreational mathematics on the 29th of January. Now, I've had a steady stream of comments over the years suggesting that rotational symmetry activities should refer to order of symmetry 1 instead of none. And, well, here's what I'm thinking. So, first of all, what do the reputable sources say? So, the NCETM glossary defines rotational symmetry as a 2D shape has rotational symmetry about a point if it matches itself after a rotation through some angle greater than 0 and less than 360. So it defines the order as the number of distinct matches in a full turn. Saying order 1 is technically true because every shape matches after 360, although this is not really very informative to say a shape has rotational symmetry if it's only got one match. Now, the GCSE revision materials commonly avoid order 0. They either write no rotational symmetry or they accept order 1. Now, many teachers prefer to say no rotational symmetry all the time in order to avoid confusion. And general references agree that order means a positive integer count of matching orientations in a full turn. So, which description is best? Well, order 0 is not correct in school mathematics because order is defined as a positive integer, so we'll discount that. Rotational symmetry of order 1 is technically defensible since the shape matches after 360 degrees turn, but it often misleads pupils into thinking there's sort of a non-trivial rotation. So my favourite is no rotational symmetry, and that's the clearest classroom language when there is no match for any angle strictly between 0 and 360. So, how to describe very irregular shapes? I would say use plain wording asymmetric with no rotational symmetry. This is precise and avoids implying any special order. Alright, the mathematics page on the website, if you haven't seen that, there's lots of tricks, and my favourite is the magic square trick, which I remember showing it to my classes many years ago when I was trying to show off the magical powers that all maths teachers have. So a couple of weeks ago I was amazed to see another magic square trick on a YouTube video that used a totally different method based on binary numbers. So this trick featured in the video John Walton's Magic Square, also known as Da Vinci Outnumbered. And the entire trick is based on a 16 double-sided cards arranged in a 4x4 grid, allowing the magician to adjust the total on the fly based on the number the audience creates. The 16 cards are pre-assigned to 4 distinct groups, and these groups allow the magician to adjust the final total of the magic square by any value from 1 to 15, or 3 to 18 as the sum of 3 dice as the trick goes. So, in group 1 on the magic square, the cards have a difference of 1 between the number on the front and the back. And then the 4 cards in group 2 have a difference of 2, in group 3 a difference of 4, and in 4 a difference of 8. So, do you recognise binary coming out here? So you can tweak and combine these differences to make any total that you need to increase the magic total of the magic square. So that's how it cleverly works. Now, I'm not sure my interpretation of the method exactly matches how John Walton did it on the video, but it certainly would work, I guess, if you had the cognitive space to do all of this. So this is how it works. The audience members, and it was Penn, Teller and Alison in the video, are asked to mentally roll a dice and call out the results. So they called out 3, 1 and 4, which sum together to make 8. Now, the cards are preset to total a specific base number, and the way I'm thinking of it is that number would be 3. The total in every row, column and all the rest of it would be 3. So the magician quickly calculates how much difference between 8 and 3 there is, which is 5. And then he uses the binary system, 1, 2, 4 and 8, to make up the 5. So it's obviously cards from group 1 and group 3 need turning over. And then when he places all the cards out, you get magically the magic square making that total of 8. And everybody was absolutely amazed. Now, I just realised that me just saying this without any visuals is going to be very difficult to follow. But if you have a look at the video, you'll see how it played out on the Fool Us program. And it certainly fooled Penn and Teller because John Walton won a trophy, a Fool Us trophy for doing that. So, yeah, bit of binary in magic. Okay, finally, the answer to last month's puzzle, which was...
2 elves, Holly and Missile, are helping to fill a magical toy sack for Santa. Working together, they can fill the sack in 22.5 minutes. The quicker elf could fill the sack all by theirself, 24 minutes faster than the slower elf. How many minutes would it take each elf to fill the toy sack on their own?
The answers are 36 minutes and 60 minutes. And if you'd like to know how those totals were obtained, go to the newsletter, transom.org/newsletter, and you'll see some newsletter readers or podcast subscribers sent in their methods, very clever methods, and they're there for you to see and learn from. So thank you very much for all those who took part. Please take part in this month's puzzle, the first of 2026. And, well, that's all for now. Oh, apart from to say, if you're looking back 6 years ago, with hindsight, you could say that you have 2020 vision. Ha!
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.